quick series here that kind of covers the basics. This is going to be geared more towards the beginners, the people who are trying to rebuild their foundation in cardiology, because with so many cardiology classes and so many programs, people really don't have a strong foundation, and I feel like that really hinders how much you can build on it, right? If you don't have a good foundation, you just can't build on that. So we're going to cover, this is like a 5-slide presentation. We're going to cover something very, very quickly to lay some groundwork. So if you're new to this, we'll jump right in and we'll help you lay a strong foundation. And if this is old to you, then a little review never hurt anybody, okay? All right, so quick reminder, an ECG is a vital sign and nothing more, okay? You don't make incredible or risky clinical decisions based on just an ECG. It does aid in diagnosis, but it should never be substitute for the patient's presentation. Your patient needs to present as critical before you make risky decisions and things along those lines, okay? Don't forget that one finding can mean multiple things. One of the ones I use as an example when I'm giving this lecture in person is cor pulmonale. So as you get into the 12-lead region of things, you'll begin to see right-sided heart strain patterns, and you'll see various diagnoses assigned to them. The right-sided heart strain that we call S1Q3T3, for example, can also be seen in CHF crisis sometimes, not just in the case of the massive pulmonary embolus. So remember that there's not a ton of absolute rules to the EKG in terms of every time I see this, it's going to equal that, okay? It's like Francis Schaeffer said, the only absolute allowed is the absolute insistence. There are no absolutes, okay? So let's move forward to the basics. All right, this is the very beginning of it all, okay? People want to jump in and start diagnosing heart attacks and all this other kinds of stuff, but if you don't understand a rhythm, you have no foundation to build on, okay? You need to understand the P, Q, R, S, and the T. So P, Q, R, S, T. Why are they labeled that way? Because so many other things in science are labeled A, B, C, and D. When they decided they wanted to label these, they wanted some letters that didn't get confused with everything else. That's what the books say. Your P wave represents atrial contraction. All right, now this is assuming that the heart is doing what the electrical system is telling it to do. The P wave means the top of the heart is contracting. The QRS, this is called the QRS complex, means the bottom of the heart is contracting. And then your T wave means the bottom of the heart is recharging, okay? Repolarization, relaxation, recharging. The P wave also recharges, but you can't see it because it happens during the QRS complex, so it's hidden. Your ECG is not unlike a police officer's radar. It can only clock the fastest car. In the same way, the ECG can only catch the highest energy charge that's coming towards it, okay? In terms of where our leads are placed and where our leads are and where our electrodes are placed. They have ECGs on some cardiac units with well over 100 leads. You can do some research into that. It's pretty neat, and I can't educate you on those. That's way out of my purview. But when it comes to the 3-lead or the 4-lead ECG, if you don't understand those few facts I just gave you, you're going to have a problem, okay? Now, all of that is laid on a piece of graph paper, which represents both time and energy, and both of those are important. Now, one of the big things people don't take the time to learn is how time is represented on the ECG. So if you look at the bottom left-hand corner here, one of the large grid squares is 0.2 seconds, okay? 0.2 seconds, that's important. One of the small boxes, even though it's not labeled on here, is 0.04 seconds. Those are important because you need to remember the time frame in which everything is supposed to happen, right? So your PR interval is supposed to be between 0.12 and 0.20 seconds, for example. Your QRS complex is not supposed to be wider than 0.12 seconds. Any wider than that is defined as a wide complex, and you know that the impulses are coming from other places in the heart, just like your accompanying texts are telling you. So take the time to memorize what each of those blocks means time frame wise, so that it's second nature, so you don't have to concentrate on it. Also, if you look in the top left, you see the 3 seconds mark. These are the large marks. This is not on every single piece of ECG paper, but there are similar ones that denote what gaps are 3 seconds. And you put two of those together to make the 6-second strip, as you see noted here in the middle. 6-second strips are very important because most of our ECG analysis happens in the 6-second time frame. Most of the activity the heart is giving off can be caught and diagnosed in 6 seconds. So when you're talking about your atrioventricular blocks, when you're talking about, you know, bigeminy and different things like that, you can usually catch it and diagnose that in the 6-second realm of things. Okay, we're going to pay a little bit of attention over on the right to the millivolt rating. One of the large grid squares on the y-axis here is a millivolt rating. That's how much energy is coming towards the lead, and that'll become more important in the next slide. Okay, the millivolt rating is showing how much energy the heart is giving off, assuming you placed all your electrodes where they're supposed to go. And in certain conditions, those millivolts drop. COPD is one of them, where the P wave will actually lose a certain amount of amplitude in certain leads, and this is a good indication you're dealing with a COPD patient, whether they've been diagnosed or not. And that's something for later, and you can see it in other videos I've already posted on here when you get into the more advanced stuff. The third thing I want to cover is Einthoven's triangle. So Einthoven's triangle, this is Dr. Einthoven was the Dutch physician who invented the first practical ECG that could be used to really see heart rhythms and things like that. There's a lot of information in front of you to be such a simple picture. Pay particular attention to lead 2. This is where you'll do a lot of your diagnosing at as far as rhythms, right, or arrhythmias to be more specific. Also look in the middle, you'll see your pie chart there. From -30 to -90 is what they call a normal axis. Axis is a direction of travel in the heart. That means that what should be happening here is your energy should be starting around the 150-degree mark and ending up around the 30-degree mark. And we measure it at that 30-degree mark because axis is usually measured in the ventricles, and there's another presentation on here that gets more in depth with that one, but you need to understand that the normal direction of travel in physics, all right, the normal direction of travel in electricity is from negative to positive. So the energy should be flowing from negative to positive. You can see from RA in the upper right hand corner, upper left hand corner, to LL in the center there. It should be going from negative to positive at an axis of between -30 and +90 degrees. If you see that, that is usually indicative of a normal conduction system. Now, there's all kinds of ways to measure axis. There's some 5-minute ECG models on YouTube that can show you how to do it with a 12 lead. There's the up, down, or down, up ratings you see in some of your textbooks, and some of your instructors know. Whichever one of those works for you, by all means, go for it. Okay, but if your ECG is able to interpret an axis and give you an actual number, you need to compare that in your head to where the normal numbers are. So you need to remember where the normal numbers are. And you can also look up axis charts on here that show what's left axis deviation, what's right axis deviation, and stuff like that. And then what's extreme right axis deviation. And all those things play into your diagnosis of certain heart conditions, because you can consistently find certain things in certain heart conditions that will let you know what you're looking at, or provide a piece of the puzzle to let you know what you're looking at. But you can't do any of that without the basics. You need to know what your PQRST is. You need to know the time that it's all happening and the millivolts that are being represented. And you need to understand the concepts of the triangle as they're defined in your textbooks and things of that nature. So jump in and spend particular time understanding that. Spend plenty of time understanding that and learning it to the T, because everything else is going to build on this, and you are going to understand so much more about this than your colleagues if you spend the time to learn it now. All right, guys, thanks for watching.